Good day friends, welcome to my channel lecture series on power electronics. In this lecture we'll see about electric drives. Drives are nowadays used in many industrial and domestic applications, and wherever speed and motion control is required, like in fans, pumps, robots, washing machine, etc., drives are made use of. And the systems that are employed with the speed and motion control of electrical machines such as motors and robots are called drives. If the drive employs electrical motors, then it is called as electrical drive. The applications of electric drives are like electric saws, drills, fans, washers, blenders, and there are single motor drives and multi-motor drives. So in multi-motor drives, several motors will be controlled using a single control system. This is a conventional electric drive. A conventional electric drive consists of the DC motor. This is a DC electric drive, and this DC motor speed and direction, if it is to be controlled, we make use of this system, which is called as a Ward-Leonard system, which was developed in 1890s. And in this case, if the speed of this motor is to be controlled, the supply voltage to this motor should be changed, and the input voltage for this DC motor is given from the DC generator. If the DC generator develops different voltages, the motor's input is also different, and so it will run at different speeds. The DC generator is requiring a mechanical input. So the mechanical input for this DC generator can be given by any type of motor. It can be a AC motor or a DC motor. In this case, the AC motor is given as a prime mover for the DC generator. The AC motor is given the AC supply. So this is a conventional electric drive where we have a motor whose speed is controlled, and for controlling the speed we have a setup like this. This is a modern electric drive. Here the motor whose speed or direction is to be controlled is connected as shown in this picture. There is a source, there is a power modulator, the motor is connected to the load, there is a feedback path in which the parameter required is sensed, then it is controlled, given to the power modulator. In the DC drive shown in this picture, the DC motor whose speed is to be controlled is connected to a power modulator, and if the available source is AC, then AC should be converted to DC before it is fed to the DC motor. This is called as a rectifier. This rectifier can be a controlled rectifier or an uncontrolled rectifier, and this is called as a rectifier fed DC drive. If the available source is DC, then if it is to be fed to a DC motor, before feeding it to the DC motor, the voltage has to be stepped up or stepped down to the required levels using the power modulator. A power modulator which converts DC to DC is called as a chopper. So this type of a DC drive is called as a chopper fed DC drive. If the motor whose speed and direction is to be controlled as an AC motor, then it is called as a AC drive. In the case of the AC motor, the power modulator can be either an inverter or a voltage controller based on the supply available. If we have a DC source, before feeding into the AC motor, it has to be converted to AC. So a power modulator which converts DC to AC is called as a inverter. So this is an inverter fed AC drive. If the source available is AC itself and the motor to be controlled is also AC, in that case the power modulator should convert AC to AC to the required level. In that case, the power modulator can be a voltage controller or it can even be a cyclo converter. So in this case it is called as a cyclo converter fed AC drive. This table gives a comparison between DC and AC electric drives. In the case of DC drives, the motor used requires more maintenance, it will be heavy and expensive. In the case of AC drives, AC motor requires less maintenance, it is cheaper, and it can run at high speeds. The control unit is simple and cheap for a DC drive, whereas it is complex and the cost increases with performance for an AC drive. Performance based, if we check, it is having a fast arc and flux control with a DC drive. Here it is not that fast. Hope this explains the DC and AC electric drives. Overall, an idea about what an electric drive is given in this lecture. Thank you.